Hi everyone. In this video, we are going to look at how to do some basic operations using decimals. So we're going to look at how to add, how to subtract decimal numbers. Also, we are going to look at other operations like simplifying a polynomial and solving equation. They are all involving addition and subtraction of decimal numbers. Let's look at our first learning objective. We want to add decimal numbers. We want to add decimal numbers. This is our first example. When we add or subtract decimal numbers, we want to line them up according to their place values. So the first one is 51.092, 23.64. So line them up. And then we can perform the indicated operation. This is the addition. Starting from the last digit, we got 2. We got 2 plus 0 still 2. 9 plus 4, 13. We have carry of 1. 0 plus 6 plus 1, that is 7. This is decimal point. 4 and 7. So that's our answer. 74.732. Now, the next example, we have 3 numbers. It doesn't matter which one you write on the top, which one is second, which one is third. So 32.09, 4.103, 19.6423. Now add them together. This is 3, this is 5, this is 13 carry, and 1 plus 6 plus 1 is 8 decimal point. This is 6, 6 plus 5, 6 plus 9, 15 carry of 1, and 3 plus 1 plus 1, that's 5. So eventually we got 55.8353. So let's double check using calculator. 32.09 plus 4.103 plus 19.6423. 19.6423. What do we get? 55.8353. 55.8353. So that's correct answer. Now let's do one more example here. This only has whole number digits. And then 0.0 is first whole number digit. 0.0189, 3.99, 3.99. So let's add them all together. 9, 8. 1 plus 9 is 10, carries 1. 0 plus 9 plus 1, 10, carries 1. 6 plus 0 plus 3 plus 1, that's 10. And carries 1, that's 8. Decimal point. We got 80.0089. And that's our final answer. So even though we have calculator, we can all use calculator to do these calculations, but we want to know the very basics in case you don't carry a calculator with you all the time, right? In case you don't have a calculator, you can still do this basic operation. Now this is our first exercise set. Now let's see how we subtract decimal numbers. And when you subtract, the first one is a bigger number, second one is smaller one. Also, you need to line them up according to their place values. This is a 2.54, and we do subtraction this time. 1 minus 0, still 1. 4 minus 4 is 0. 9 minus 5, that's 4. Decimal point. 8 minus 2 is 6. 5 minus 0 is 5. So the answer is 56.401. And this one is very straightforward. Now let's look at the second one. we have a whole number, subtract 48.165. Now, if there's no digit here, decimal digit, it means 0. You can put 0 here if you want, but you don't have to. Now, apparently 0 cannot minus 5, so we have to borrow, but this is 0. There's nothing to borrow. So we have to borrow from the previous digit, and this one also 0. Eventually, we borrowed from here. When you borrowed, it's like you borrowed one unit from here. Say 1 unit, and if we borrow 1, imagine this become 1 and this 9 become 1 and 8. So you have 1 in here basically. So this become, if you don't look at this decimal point, this become 1,000. Basically, you're going to use 1,000 subtract 165. So this is like 0. Eventually, this 1,000. When you have 1, and this is 0. Borrow this 1. Borrow 1 from this one. This become like 10. This become 10. This become 10. All become 10. So 10 minus 5 is 5. Since you borrow 1 from here, this become 9. 9 minus 6, that's a 3. Also, this original borrow 1 from here become 10. Once this digit borrow 1 from here, become 9. 9 minus 1 is 8. After you borrow 1 from 9, it become 8. So 8 minus 8 is 0. And 7 minus 4 is 3. 1 minus 0 is 1. So 130.835. Now, to simplify this whole borrowing thing, we just look at this one as 1,000, basically. 1,000 minus 165, what do you get? You get 835. After you borrow 1, the digit 8 become 9. Digit 9 become 8. So 8 minus 8 is 0. So let's double check. 179 minus 48.165. 48.165. 130.835. So 130.835. Our next example, 98.036 and 9.482. We're going to have borrowing again. 6 minus 2, that's 4. We cannot minus 8. So we just borrow 1 from here. Later on, we borrow from here to make this become 1. But for now, let's just say we borrowed 1 from here. When you borrowed anything, it become 10, okay? Because the previous digit always 10 times bigger than the current digit. There's a prior digit, okay? So it becomes 13. 13 minus 8, that's 5. Now, when you borrow from here, it's 10. Because it's 0. 10 plus 0 is still 10. 10, since you borrow 1 from here, it becomes 9. So 9 minus 4, that's 5. After you borrow 1 from here, it becomes 7. 7 cannot minus 9, right? You borrow 1 from here. Any unit, prior unit become 10. Okay, this is 17. 17 minus 9, that's 8. This only has 8 left. So in the end, we get 88.554. So let's review this process quickly. 6 minus 2 equal to 4. Now this one is 3. I have to borrow. And borrow, you get 13. 13 minus 8, that's 5. Since it's 0, 0 is equivalent 10 after you borrow 1 from here. So after you lend 1, 2, 3, it's become 9. 9 minus 4 is 5. After you borrowed 1 from 8, it becomes 7. So 7 cannot minus 9. That's why we need to borrow from this digit. So it becomes 17. 17 minus 9, that's 8. So this 9 become 8. So double check. 98.036 minus 9.482. 9.482. 88.554. 88.554. Second exercise set. Now, let's say we have operations with signed numbers, and we learn how to add and subtract signed numbers, but they are whole numbers, right? This time we have decimals, but the way the logic behind this process remains the same. So here we have a negative number, which is larger in size than the positive number. So we know the answer is going to be a negative number. The net result is negative. But the way we do it is that we want to do subtraction using bigger number minus smaller number. 15.79 is 8.4. The reason we do subtraction is that when you have one positive number, one negative number, add together, the result is difference between these two numbers. For example, -3 plus 2, that's -5 plus 2 is -3. How do we get 3, this number without sign? Is the difference between these two numbers. That's why we do subtraction to get difference first. Then we look at which number is larger in size to determine the sign. Okay. Now we do subtraction. 9 minus 0 is 9. 7 minus 4, that's a 3. This one is too small, so 15 minus 8 is 7. I get 7.39. But since negative number is bigger in size, the result is negative. So negative 7.39. Now, second one, this one is easier actually. Both are negative numbers add together. The result is even more negative. Whenever you have two numbers with the same sign, when they add together, you only get a bigger number in the same sign because they go in the same direction, both negative, they add up. So basically, we just need to add these two positive numbers together and then give a negative sign in the end. 5 plus 0 is 5. 9 plus 5, 14. Carry 1. 8 plus 4, 12. 13. Carry 1. That's 8. So we get negative 83.45. That's our final result. Another set of exercise problem. Now, next example, we look at subtraction of some numbers. First, 0.08 subtract 5. Apparently, smaller number minus bigger number, the result is negative. The way we do it though by hand is that we always use a bigger number subtract smaller one. Again, subtraction means the difference between two numbers. That's why we still do subtraction. But general common logic is that we use a bigger number minus smaller one. So 5 minus 0.08. So this 5 is equivalent to 5.00 if you want to add zeros. So 0 minus 8, you cannot minus 8, borrow 1, become 10. 10 minus 8 is 2. And this one has to borrow 1 from 5. When you borrow 1 from 5, become 10, but it lend 1 to the next digit, become 9. So 9 minus 0 is 9. And this becomes 4. 4 minus 0 is 4.92. But the result should be negative because smaller number minus big number, the result is negative. Negative 4.92. Now let's use a calculator. I'm sure this is correct, but let's just verify. 0.08 minus 5. I satisfy by push 6 equals negative 4.92. Now this one we have negative 16.2 minus negative 9.07. Minus negative equals to plus. Okay. You can also say negative become positive or minus equals plus, either way. negative 16.2 plus 9.07. So again, whenever you have addition between two numbers with different signs, actually the result is difference between these two numbers. And this number is bigger in size, negative number is bigger in size. So net result will be a negative number. So we just use 16.2 minus 9.07, and we know the result is going to be negative. And 0 minus 10, just 10, borrow 1. 10 minus 7 is 3. This one become 1 after 0, borrow 1 from this digit 2. So 1 minus 0 is 1. 16 minus 7, 16 minus 9 is 7, 7 is the result. So 7.13, the result is negative 7.13. And exercise, like in any video, the answers to this exercise problems is in the comment area below the video. Now our next objective, we want to simplify a polynomial with decimal numbers as coefficient, or whole numbers. When we simplify a polynomial, when we add or subtract, in algebra, we want to combine like terms. That means the terms whose variable part are exactly the same, like n squared term. We have another n squared term. These two are called like terms. You can only add like terms or subtract with like terms. So these two will be combined. So basically, this is the 4.2. Let me rearrange this so that you can see that 4.2 n squared. And this is a minus 10 n squared. The next one, we're going to have n terms, minus 6.1 n plus 2.35 n. Then we have constant numbers, which is positive 9, so plus 9, all positive, 2.09. Let me confirm we have 6 terms, 1, 2, 3, 4, 5, 6. Okay, 4.2 minus 10. And this is not about basic calculation anymore. This is about simplifying a polynomial. For that reason, we're going to use calculator to do this calculation. 4.2 minus 10, we're supposed to get negative 5.8. So negative 5.8 n squared. Then negative 6.1 plus 2.35. So for my calculator, this is negative sign. So make sure you can tell the difference between negative sign and the minus. They are not the same. On my calculator, this is the minus, this is negative sign. So I get negative 6.1 plus 2.35. 2.35 equals negative 3.75 n. Then we add these two numbers together, both are positive. So 9 plus 2.09. We get positive 11.09. So this is our final answer. Usually when we write a polynomial, we always write the term with highest exponent first in the descending order. There's the 2, there's the 1, there's no variable in the past term. Now, here's the exercise set. And we have more examples simplifying a polynomial. So let's look at example 8. We have parentheses here. Parentheses is totally unnecessary because this is addition. And the reason we use parentheses in this example just show people we have two polynomials adding together. So this is the first polynomial, the second one. Otherwise, there's no need to have this parentheses. So for that reason, I just remove the parentheses first. So 8.2 y cubed minus 6.1 y squared plus 10.65. Then plus y cubed minus y minus 12. Now it's time to combine like terms. So this is a y cube term. This is also y cube term, both positive. 8.2 plus 1. If there's no number in front of it, in front of a variable, it means 1. So 8.2 plus 1, that's 9.2 for y cube. So these two are gone. Now next one in line is y squared. We only have one y squared term, so we just copy this term. Minus 6.1 y squared. After y squared term, we have y term. And we only have one y term again, so we just copy that, minus y. Now we need to combine these two together, positive 10.65 minus 12. So 10.65 minus 12 is supposed to be negative 1.35. So negative 1.35. Yeah, that's our answer. It's not hard. We just need to be careful not to make basic calculation mistake. Now let's do one more example. So this time we have subtraction between two polynomials. And this time the second pair of parentheses is necessary. The first one is not because there's no operation in the front. So I just copy this whole thing inside without parentheses. 15x squared plus 8x minus 7. Now, when you have subtraction outside parentheses, you're supposed to minus each term inside because this whole expression is composed of 3 terms. You are subtracting the whole expression. It makes sense to subtract each one of these terms inside the parentheses. So minus 1.1x squared minus x, minus is plus, so plus 9.1. Now we are ready to combine like terms, x squared term, x squared term. So 19.15 minus 10.1. 19.15 minus 10.1. 9.05. So 9.05 for x squared. X term is 8, positive 8 minus 1. 8 minus 1 is 7. Now we just have negative 7. Don't forget negative sign. Negative 7 plus 9.1. Negative 7 plus 9.1. We get 2.1 positive. Yeah. So we just simplify it. This is your exercise problems. I have 4 of this long ones. Practice, right? That's why we, in learning mathematics, everybody should do enough exercise problem. Just make sure we gain the basic skills so that you have easier time when you move to the upper level courses. Now, next learning objective, we're going to solve some equations. This one example actually, using the addition principle. So the general principle, no matter how many different ones we have, is that when you solve an equation, you want to have that variable on one side by itself in the end. And the other side is a number. We call it answer, right? That's our general direction. So in other words, we don't want this 4.78 on the left-hand side with n. We want to get rid of it. How do we get rid of it? In general, in any textbook, they would say you need to do opposite operation. You do minus 4.78 on both sides. That's totally fine, no difference. And usually, when I do examples in the classroom, usually I just show people how to do things intuitively. So in other words, if we don't need this term, we just simply move it to the other side. So n equals negative 5.62. Whenever you move a term to the other side, you also change the sign of that term to the opposite sign. So minus 4.78. The reason we change the sign to the opposite, because you move this term to the opposite side, left-hand side, right-hand side. Now let's do a analogy here. 10 minus 2 equal to 8. You know that's correct. Suppose I want to move this minus 2 to the other side. If I don't change the sign, okay? If I don't change the sign, it's not going to be equal anymore. I have minus, I still have minus after I move it. Without changing the sign, this is wrong. But if I change the sign to the opposite, it's still correct. So make sure you change the sign to the opposite after you move a term to the opposite side. Now our we need is negative 5.62 minus 4.78. So we can use a calculator. Negative 5.62 minus 4.78, negative 10.4. So we solve it. It says solve and check. So if we replace n with negative 10.4 plus 4.78, we should get this number. So let's do it. So negative 10.4, I already have that on the screen. I just add 4.78 to it. Equals negative 5.62. That's the correct answer. Exercise. Oh, basically this is the last one for this video. This is your exercise problem. That's all. See you guys in the next video.